This is the May 2014 SL exam, paper 2, time zone 2. We are given a trigonometric function. We can see that there are some constants there. We know what the 10 is, but we don't know P, we don't know Q, we don't know R. But we are given a graph. So let's figure out what's going on with this graph. First thing to notice, it asks us to find the value of R. So this is a value inside the function. You might recall that when we're talking about transformations, when we have a shift of 4 units like this, so f of x minus 4, this corresponds to a shift right by 4 units. So the thing that was a little bit counterintuitive when we did this before is that when we add or subtract constants inside the function on the inputs like we have here, the shift is kind of not in the same direction as we would expect. For example, so this is x minus 4. You might think that it would move left 4, but it doesn't. That actually corresponds with a shift right by 4 units. This is a cosine function. Cosine, we know, starts at a maximum value, which means that the start of the cycle of cosine is actually here at that maximum value, which means that this cosine has been shifted to the right by 4 units. Part A asks us to write down the value of R, and from this, a shift to right by 4 units means that that value inside needs to be -4. Which is the first one. Second thing is it asks us to find P. P is on the outside, and we know that anything multiplying the outside function is going to stretch the y coordinates. So 2 f of x is going to multiply all y coordinates by 2. So I'm just putting this in there just so that we're reviewing some of the ideas of transformation, in case you've forgotten these. Okay, so we're multiplying all the y coordinates of f of x by 2. That's what 2f of x would mean. Let's figure out how the graph has been stretched in this case. So we can see by kind of maybe drawing the center line here, normally cosine goes from -1 to 1. About the center line, about that mean value for the function. We can see from this that this function is going from 18 to 2. So that means above this center line and below this center line, we can figure out that distance above and below, this is 10 and this is also 10. So from this, we can observe that the y values, in comparison to the regular cosine, which goes from -1 to 1, these y values have all been multiplied by 10, which tells you that this p value has to be 10. Now, we also came up with another way to come up with this. P is, the absolute value of p is actually the amplitude. And another way to find the amplitude is just to take the max value and add it to the minimum value. So we have 18 plus 2, take the average, that's 20 over 2, which also gives us 10. So that's another way to get that. And finally, for part Q, it asks us, find the value of Q. Q is related to the x value. So when we have a number that is inside, again, so let's say, let's make it qx. Okay, this means that all of the x coordinates on the original graph are divided by 2, or divided by q in this case. So we think about what relates to a trigonometric function and the x coordinates or lengths or distances in the horizontal direction, and the significant part there is just the period. Okay, we can figure out the period of this graph by looking at this maximum value and that minimum value. And we can see that between the maximum and the minimum, that's actually half a period. And the way to kind of visualize that is that if this graph continued, in order to get back up to a y value of 18, we would have to sort of do the same trip that we had done to go from 418 to 16.2. So this is half of a period. And that distance is just the distance between 4 and 16. So that's going to be 2 times that distance of 16 minus 4, which is 12, which just means that the period is going to be 24. Normally, the period of a trigonometric function is 2 pi, so we can see that that 2 pi has been divided by some factor in order to make the period 24. We had a couple ways of doing this. You could memorize that t is 2 pi divided by q, which would give us then that q is 2 pi divided by the period, which is 24, telling us that q is just pi over 12. That's the exact value. You could write that as a decimal because this is a paper 2, but this is simple enough to write as an exact value. The other thing that we could do is that we don't know that value of q, so what we could say is we know that the period is 24, and we know that that has to be the original period of cosine, which is 2 pi, divided by some factor q. That's just coming from our knowledge over here related to transformations. So from that, we would get the exact same value, that q is equal to 2 pi over 12. The final thing in this question is we're asked to solve f of x equals 7. We have all of the parameters now for f of x, so we know that we have let's see here. Oh, I am realizing now that I made a mistake up here with that p-value. 18, that should be 18 minus 2 over 2. Sorry about that. 18 minus 2 over 2, and that gives us 8 instead. So p is not 10, p is actually 8. And so now going down into f of x, this means that f of x is given by the equation 8 cosine of our pi over 12 times x minus 4. And we are setting, plus 10, of course, and we're setting that to be equal to 7. This is paper 2. Notice that it's only 2 marks that you get for this question, so you're really showing in some way that you are solving this equation, and then you can just use the calculator to find solutions. And the solution you get is that x is approximately equal to about 11.4683, but of course we're going to report that answer to 3 sig figs and write it as 11.5. And one option that IB gives you is if you come up instead with coordinates of 11.5 and 7, that's also an acceptable solution. All right, so that'll do it.